If classical physics was correct, atoms should not even exist. So why don't electrons fall into the nucleus? Welcome to Nano with Zidyep, and in this episode, I will introduce the basics of quantum physics, explain Rutherford's model of the atom, why it failed, and how a new idea changed everything. So, what is quantum physics? Quantum physics is the branch of physics that explains how matter and energy behave at a very small scale, such as atoms and electrons. At this scale, classical physics no longer works and new rules are needed. Ernest Rutherford proposed that an atom has a dense positively charged nucleus at the center, with electrons moving around it like planets around the sun. That means most of the atoms is actually empty space. But there was a major problem. Electrons are charged particles, and according to classical physics, any moving charged particle should lose energy. So the electrons should continually lose energy, spiral inward, and eventually fall into the nucleus. But this does not happen. Atoms are stable. So this is a law that we all know, but then atoms are still stable. This means that Rutherford's model was incomplete and classical physics could not explain atomic stability. Max Planck, this is where Max Planck introduced a revolutionary idea. Planck proposed that energy is not continuous, but then he gave these three proposals, which are energy is not continuous. Instead of flowing smoothly, energy exists in small packets. They exist in small packets. They do not flow continuously, like how water is rushing out of tap continually. But instead, energy flows, like for example, the way I would depict it, or the way I actually understand it, is that it comes like in a beep, 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 just like a beep sound. Do you understand? In packets. And that packet is also called quanta. So that's how they are. And energy is quantized. That's the second um, proposed rule by Max Planck. Energy is quantized. These packets are called quanta, which you just said, meaning energy is transferred in discrete units. Electrons have discrete energy levels. Electrons cannot have any random energy. They can only exist at specific energy levels. So they cannot just have any random energy. They only exist at specific energy levels. This explains it. The statement explains itself. Each energy packet is given by the equation E equals to hf. Here, E is the energy, F is the frequency, and H is Planck's constant, which is a very small number. So this means that the energy depends on the frequency. So you said E is equals to Hf, but then H, which is Planck's constant, is a very small number, and so it's insignificant, making E dependent on H. But when I say insignificant, I do not mean, but it does not really affect it in a huge major way to make energy not be dependent on frequency. That's basically what I'm trying to say. So instead of energy being continuous, it comes in fixed amount, and electrons can only absorb or emit this specific amount. Let me read this again. So instead of energy being continuous, it comes in a fixed amount. So it's not continuous, like it does not come, it's in a fixed amount. And electrons can only absorb or emit this specific amount that it comes in. So this idea helped solve the problem of atomic stability and led to development of quantum physics. So the idea that energy is not a continuous flow, but then it's in discrete units, which is quanta, which I made an example. I said it's like beep, beep, like it comes in a packet. Do you understand? And Quantum physics changed the way we understand matter and energy at the smallest scale. So, I think this basically what we're talking about, and in summary, is just as saying Rutherford had he had a model of the atom, and then unfortunately that model was not standard because there was a question like, okay, since the electron is in continual motion, why doesn't that electron lose energy? And that's one of the basic law of classical physics, that when an electron is moving, it's meant to lose energy, or a charged particle is moving, it's meant to lose energy over time. But then unfortunately that is not the case. So that means it's either classical physics or thousands of years of classical physics is wrong, or the model of atom by Ernest Rutherford is wrong. But then we tend to understand that the way we understood energy initially was not the case, and we by Max Planck, he introduced a revolutionary idea where he brought three things like energy is not continuous, energy is quantized, and energy have discrete energy levels. So this whole idea that he brought out, it's what brought the bedrock of quantum physics, and uh, could explain matter and how energy really work at that very small scale. So this is Nano with Zidyep, and in these videos or in this journey, I document my learning, I improve communication skills, and we just improve day by day. So if you have watched to this extent, thank you for listening, and I'll see you in my next episode. Peace out.